So hi everyone. Today let's design a chat application like WhatsApp, and we will try to cover all the aspects of it in depth as well. So chat application like WhatsApp, we use it in everyday life. We will try to deep dive into every part like how messaging works, how group chat works, and all this stuff, right? Without wasting a time, let's go into the functional requirement of a system. What are features that we want to be in our WhatsApp? So as we know, WhatsApp do have a feature of one-to-one messaging. The other feature that we can think of is group messaging. Other thing is group management. We can see group management, which include add or remove member from a group, right? The other functional requirement that we can think of is the status, users online status. If the user is online or offline, we can figure it out, right, via blue dot. The other feature that we can think of is the message delivery and the message status like read receipts and all. This is, we can think of the functional requirement right now. Now we will try to estimate the scale of a system, and through them we can come to our non-functional requirements. So coming on to the scale of WhatsApp serves like more than 1 billion users. So let's say the daily active user for a system are 1 billion. Out of which, let's say everyone, each user sends in a day at least 50 messages, right? So the number of messages per day will be 1 billion into 50. That comes to be around 50 into 10 to the power 9, right? This is messages per day. Converting into messages per second, we know that each day have 24 hours, each hour has 60 minutes, and each minute has 60 seconds. So one day has like 86,400 seconds. We can estimate it to be roughly 10 to the power 500k. So the number of messages per second can be estimated as 5 50k messages, 500k messages per second. That's huge, right? So for 500k messages per day are sent across through our system every second. Coming on to, this is the huge scale of our system that we need to handle. Now coming on to the non-functional requirement, and we can also assume that in the messages we will also support media like images and video, right? uh, Media should also be allowed. Yeah. So the non-functional requirement for a WhatsApp will be, the first will be, as we know there are 1 billion users, so our system should be crazy highly scalable. Highly scalable to support 1 billion users across the globe. Now coming on to the cap theorem, we want our system to be highly available. Available 24/7 across the globe so that everyone is able to send and receive messages. Again, the 99.99% uptime should be there for our system. The next thing is we must guarantee the delivery of messages even if the user is offline, right? So our system must be reliable. That means message must be guaranteed even if the user is offline, right? Now the other non-functional requirement that we can think of, I think that's pretty much we can always come back and update our list here, right? So coming on to the core entities of our system. Yeah, as we discussed earlier, these are basically the nouns that are present in your function requirement. So first and foremost is users. The other core entities are like group, I can see, or so let's go, let's say message. Other is group. Then the next thing is basically yeah. So these are pretty much the entities, the core entities that our system must support. Coming on to the next part, that is API. Yeah, so the flow of our system design must be like, this is a better approach to go with first. List down all the requirement, functional and non-functional requirement. Then we must go through the core entities and APIs that are client, all the basically client-facing APIs. After that, we should go to design a system at a high level which supports our functional requirement. Then we should like scale it to support the non-functional requirement. Yeah, so now come the next part will be API designs. APIs. So the first API is obviously send and receive messages. Send or receive message. Again, we try to keep it in the form of versioning. So yeah, now here we need to discuss what should be the type of this APIs. Do we consider, should we use it a REST API, or should we go with something else, TCP connection? So let's say when we use HTTP and when we use WebSockets. So HTTP connections are basically a one directional connection. From client basically asks the server for something, and if it is available, server responds with that, right, immediately. But in the case, let's say we are using HTTP for our use case. So whenever a user is sending a message, let's say I'm user 1 and I'm talking to user 2. So whenever I'm sending a message to user 1, I'll simply hit HTTP request to send message. But in order for user 2 to receive a message, he need to constantly keep on asking the server, is the message available, every time. So there will be too many requests onto our server. It will be really tough for us to handle that. So HTTP is a bad option to use here. Other thing that we can go with is the long polling. Long polling is basically we once call the server, is the message available, then until the message is not available or our timeout occurred for our HTTP call, till then the connection will be there from client to server, and server will be sending, once the server receives the response from the user 1, it will send us the message and the connection will be dropped there. It will drastically reduce the HTTP call, but still for every message we need to do a long polling, right? So still that's a bad idea. Other type of connection that we can think of is server side event. As soon as server receives a message, it should connect with the client and send it the message in real time. This can be done, but here the problem with us is this is only from server to client. It can be done via client to server. So in order to send a message, let's say I'm talking to someone and sending 500 messages a day, so I need to call it like 500 times HTTP call. So that's not a good idea. So the best thing that we can do is a WebSocket connection. So WebSocket connections are basically a duplex connection, which is basically a bi-directional from client to server. Client can send a message anytime to the server, and server also can send messages back. So yeah, so WebSocket fits our use case. So we'll go with a WebSocket connection for sending and receiving a message. So let's say it's a API slash v1 slash send, we can call it, yeah, send message. The body of this message will be the content of our message. The content can be of two type now. One is basic text content. The other thing that can be of a media URL. We might be passing, we want to share some photos and we can do that. Other thing is the timestamp, at which time the actual message was sent to the server. Why do we need that? I will tell you later, but at the higher level, this will basically help us to maintain the ordering of a message, right? Yeah. So this will be the send and receive message. The other API that we can think of is checking the online status. So in order to check that, check status. So this will be a simply, we can use it, since we wanted to check the online status too frequently, so this must be also be a WebSocket connection. We can go via existing WebSocket connection as well and the new WebSocket connection as well as. So WebSocket connection, this will be a simply status to ask the online status for the other user, right? So we can simply call the user ID, right? The third thing that is coming to for the group management. So there will be this, since the group management is a one-time thing. Once I create a group, once I add a member, so this won't be. So the HTTP will help us with that. So first will be the post API. In order to create a group, API slash v1 slash group slash create a group. What all thing it needs in the body. You might be thinking why I'm not sending user ID every time in the body. We can do that for the security reasons via headers. So that makes our API call secure from external things. So yeah, so the body for creating a message will be simply the name of the group that you are creating, the description, again the time at which the group is created, and we can also pass the list. At the time of creating group, we can allow user to add members as well, right? So we can also part members as a list of phone numbers might be. Internally we will derive the user ID from phone number, right? So yeah, this is group creating. Now other thing will be add a member to the group slash group slash add add a member. So in order for this, the content will be simple. Again, the phone number of the user that we want to add, and the other thing, we can add a timestamp at which he has joined the group, right? Similar API will be there for removing him from the group. So yeah, these are basically few APIs that we can consider. Yeah. So this is the broader picture of our system. We can always come back and update anything if we need while designing a high level. So now coming on to the high level design. So yeah, we will try to design a basic thing which will satisfy our functional requirements here. So first thing will be we will be having users. Now, since you know that we have two type of API call, one is the WebSockets, other are the basically HTTP. So we need two separate API gateway. Most of the modern API gateways works both, but the scale of the system is super high. So we should consider having different separate load balancers for WebSocket and for HTTP. So these are basically the API gateway. API gateway. So I'll try to put it in center. So the first will be our layer 7 API gateway for HTTP calls, and the later one will be for the layer 4 API gateway, which will be basically for UDP request and the WebSocket connections, right? So yeah, the major role of API gateway is to authenticate the request, is to route the request to the correct server, and we can also place a rate limiter here in order to block the request coming from client by too many, right? Yeah. So yeah, let's go. First we will try to do tough things. Let's say we are trying to talk about the sending and receiving messages. So we will go here with the microservice architecture. So what all things our system, what all services you can think of a system will have. First will be the group service for group management. Group service. The other service will be chat service, right? Other will be the chat service. Do we need anything else? We are not tracking about the message. Yeah. So one will be the chat service. So whenever a user is trying to create a group, he will call the group service API in order to create the group, and we will be having a database which will store the details about the group DB. We will decide later what should be the correct database that we can have here. But for now, once a user has created like create a group, the API call will be go here, and from here we can obviously create group with details that we have discussed earlier in the API. Other is like add member. Other thing that can be is remove member, and this API is right via group service. The other thing that we should also support group messaging, right? So that will be served by a chat service itself. So now coming on to the chat service, so users will try to set up a WebSocket connections with our server, with our chat service. Once the connection is sent, now there can be two cases, right? If let's say I wanted to send a message to user 2, and I am user 1 and I want to send a message to user 2, so there can be two cases, either user 2 is online or user 2 is offline. If the user 2 is online, then I can simply check the server through which the user's WebSocket is connected, and I can simply send the message via that WebSocket in the real time. But what if the user is offline? For that case, we must need to store the messages into our DB, and once he is online, then we need to pass it at that time, right? Yeah. So we need a database in order to store the messages. Let's call it a chat DB. Yeah, this will be our chat database. We will discuss in the deep dive what should be the correct database that should be and all. So this is the basic functional requirement that will tell us how it will be done. Remember DB value storage. Yeah. So this satisfies our functional requirement regarding group management. Users one-on-one messaging we can do with. For the group messaging, what we will do, we will check all the members of the group. Let's say I'm user 1 and I'm sending a message to one of my group which have like n number of users. So what I will simply do, when the request will come to send message, I will first derive all the members that are there for that group, right? And try to send one-on-one messaging for each one. I iterate over all the members and send the messages to them via WebSocket connections. Okay. User management we done. Group management, user. Yeah. Now user online status, how we can check that, we will discuss that in the deep dive. So yeah, this is the basic we can think of. Now let's discuss the database. What will be each database type and how we will be storing the data there. So for the Postgres database, there, as we know, there are not too many transactions out there, and there are some few relations between each group and the member. So we should go with Postgres database here. That will be a good choice here. Postgres DB, and the table that should be, is first table will be obviously a group table. What it will have is the group ID, the name of the group. The other thing that we can see is the description of the group. Other metadata like created it, we can discuss that. Other thing that group must have is the yeah, we can go with two. Either we can directly store the member IDs here as an array, but that won't be a good idea here. So we can normalize it and keep a separate table for that. So yeah, for other metadata like created at and all this stuff. The other thing that we can have here is second table, that is member table. For each member, what it will have now, the ID of the member, the group ID to which this user belong to, the name of the user, the phone number, and the status of the user, either he is online or offline, right? Yeah. Since this the member table hold the activity status of the user, we can have it like we can use this for now to serve this functional requirement, users is online or offline. How will we update it? Now coming on to that part, yeah, we will come to that later, but let's define the chat database, how it will look, what all table will it have and all. So as we discussed, the scale of our system is super high. That's a 500 messages, 500k messages per second. That's really huge. If we are, let's say we are going with Postgres database, the capacity of Postgres database is to handle just 2 to 4k 2k to 4K requests per second, 4K QPS per second. That won't serve our purpose. If we wanted to go with the Postgres database, then we need to again group the messages into batches and then try to do a DB call, but that will again introduce a latency. So yeah, we should not consider that. The other database, so we need a write heavy database for our system. So we can go with the Cassandra DB here, right? Cassandra DB. Cassandra DB is a highly write optimized DB, write heavy database, and it internally it uses LSM trees in order to store the data. Basically, it first store the data into in memory and then write them into the disk in the sorted fashion in the SS tables. So whenever we are trying to query a messages, it we can simply go through the sorted order, and it is also the append only, so we don't need to go into the depth of the database, we can find it easily. So this is highly optimized for write heavy tasks. So yeah, so the table that we will be having is the chat table. First will be all the chat. So what the all the chat table will have is basically the chat ID. We can also have the sender's ID, who sent it basically. We can also keep a receiver ID, but that will be the bad idea to do that. Instead, what we can do, we can store a content here, but again that we should keep it we could normalize our database and keep a message ID here and the other metadata, right? Other metadata, yeah. So now we will also have a message table. What it will have is the message ID, the chat ID that it belongs to, and actual content of the message. That is basically a text consent. Also we can have media URLs for some media. Yeah, that is basically it for the messages. Now let's say if we haven't mentioned anywhere the receiver ID here. Why? Because if we can simply add it here as well, right? The receiver ID. But now in order to track the status of each message, whether it is delivered to that or not, we should not keep it here. This is the entire chat for the entire group, let's say 1 to n people. This is storing that thing, but the message is the one which should be mapped to each inboxes, right? Let's say in a group we have 10 people, so for each 10 people it is message is sent separately to all, so we are calling it, let's say, 10 inboxes. So inbox will have the ID, each inbox will be sent with a message, so we are having a message ID. Now each inbox can have its separate status, so we can call it the delivery status or the simply status of this message, delivery status. And yeah, and we can also have the actual receiver ID for which this inbox is receivers ID, right? So yeah, this will be our Cassandra database and it will be highly optimized for writing too many messages out here. So yeah, now we have designed our database correctly. Now let's come back into some of our non-functional requirement. Is our system highly scalable? No, we have only single instances of each services, so we will horizontally scale our services here. Horizontal scaling is basically making multiple instances of your services. Now coming on to the chat service. Chat service will also, let's talk about this, how the message flow will be. Let's say user 1 want to talk to user 2. Let's say we have user 1, he wanted to talk to user 2. How the entire flow will be? So user 1 first sends a message to our server via WebSocket. Then our server will, let's say if we have only single server, then we are damn sure that the WebSocket connection for user 2 will be also to that same server only. So our same server can handle the thing. Either if he is online, then directly send the message via his WebSocket connection, as well as process it to a DB. But the other thing is, if he is offline, then we need to process to a DB, and once the user is online come again, then we can send the messages via our database. But what if we have, since the scale of our system is huge, so we will be having the multiple instances of our services, right? So how we will keep came to know that which user is connected to which server via WebSocket, right? So we must maintain some registry kind of thing. So what we will do, we will maintain a WebSocket registry, we can call it WebSocket to server registry. What it will keep track is, it will be store basically a key value pair, and the key will be the user and the value will be the server. This user is connected to which server via WebSocket. Like, so let's say user 1 is connected to server 1, user 2 is connected to server 2, user 3 is connected to server 2. Like this kind of thing we can store as a key value pair into our Redis itself, Redis cache, so that we can access it quickly, right? So yeah, so once now how the message flow will, since our system is scale and each user is connected to different servers, right? So now let's say user 1 want to send a message to user 2, how the entire flow will be. Let's say user 1 sends a message, send message by user 1 to user 2 and actual message. So how the flow will be, user 1 sends a message, now we will check the WebSocket registry which server user 1 is connected to. We came to know that user 1 is connected to server 1. Now he want to send a message to user 2, so we will simply check the user 2 is connected to server 2. Now since we can't directly push the message from server 1 to the WebSocket connection of user 2, right? So first we need to send the message from server 1 to server 2. So how the flow will be, user 1 will send the message to server 1, server 1 via the help of WebSocket registry identify which server user 2 is connected to, and then send the message to that server, then from that server the message will be delivered to actual user 2. So this how the flow will be, right? Yeah, so there is a one thing. Now coming on to the part of how the user will know the online status, or how we can know the online status of each member. So what we can do is, for that purpose, with the help of WebSocket registration, with the help of this only WebSocket, we can maintain the user 1 status in the cache itself. We call it a heartbeat method. So user 1, with the help of WebSocket connection, all the user will update their status into our Redis, and how it will be, user ID, that's the user 1, and is he active or not active, let's say active, with a given TTL. We can configure the time to leave or the expiry of this key, let's say 30 seconds. So in every 30 seconds each user will send us a heartbeat message telling he is active or not. If we did not receive a heartbeat in 30 seconds, then with the help of the TTL this key will expire and we came to know that user is not active right now. So whenever we are checking the activity status, we can simply call our Redis cache and tell us if the user is online or not, right? So let me write it with the help of heartbeat mechanism. So this is like simply sending a heartbeat, right? We'll say user 1 active. Every 30 seconds this heartbeat message will be sent to our Redis cache and we will store it there and we will serve the activity status from here. Now coming on to the part of one-on-one messaging, we have explained in detail. We will talk about the media a bit later. Let's talk about the group messaging, how the group messaging will work. Now let's say user 1 want to send a message to group 1, right? Yeah, so send message by user 1 to group 1 and the actual message. This can be the format of send message, like we can use polymorphism internally in order to satisfy that. So when the send message request will come to user 1, with the chat server first try to resolve all the member of group 1 from a group service, right? It will ask for all the members of the group. Get all members of group 1. Now this will give us the list of all the members present in that group. Now we will iterate through each member and send this message like one-on-one messaging. So yeah, we can now keep track of the delivery status of each member inside a group itself. So this will be the flow for the group messaging. Users online status, we did that. In the message delivery, we can track via delivered or not. How it will work is, once the message is sent to the user, we, we will get the acknowledgement from the client the user have received the messages, and we will update the delivery status here. Once the user reads the message, we will also get an acknowledgement, and we will update the delivery status to rate, right? So this is the how the acknowledgement flow will be. Now the next thing will be, we have done message delivery, online status. Now the one-on-one messaging or the group messaging with media, right? Our system is now highly scalable because we have scaled it horizontally. Our system is highly available because we are storing message into database, and we do have multiple servers. So if any server goes down as well, so different other servers are there, and we can also use the auto scaling group, which will auto scale our servers based on the demand. Reliability, we are guaranteeing messages. Yes, we are storing into database. Once the user come back online, we will check if there are any undelivered message to him. We will then and there deliver him via the new WebSocket connection that he will register while coming back. Now coming on to how we will store the media. So when the user will send a message, let's say he want to upload a media, whenever he clicks on the upload media button, what we will do is, we will, so we don't want to bombard a server with the heavy media because the media size can be super high. So it will consume too much compute power of our server. So we don't want that. So basically what we do is, in order to store the media, we use a blob storage like S3 or something, right? S3 or GCP kind of thing we can use for storing the media. So what will happen, whenever the user clicks on upload media, without going onto the WebSocket connection, what we will do is, we will simply give him the pre-signed URL. Pre-signed URLs are basically, so what are pre-signed URLs? These are basically our TTL URLs which can be expired after some time. So let's say when a user clicks on the attachment button in order to upload some video, what we will do, we will generate a pre-signed URL and send him. That will expire after some time, let's say 10 minutes. So till then he can upload it to our S3 directly. It will request pre-signed URLs. We will send a bunch of pre-signed URL to him, and at the time of sending a message, inside the message we do have a field called media URLs. You might have said, inside the message itself we have the media URLs, right? So here user will pass all the media URL, and our media will be stored at the S3, so our database won't grow huge. So this will be how we will be storing our media. Now common question that are asked in during the interview is, like, the one thing is, what if, like, if the message size is high, let's say 100, if we are sending, let's say 500k messages per day, right? 500k messages per day, and let's say each message size is, we can say, like, it is a string, but each character counts to 1 byte, so the message can be long as 1 kb too, right? So 500k messages of 1 kb each, then the size, the space, this is for per day calculation I am doing, which can be simply 500 MB, right? Which can be roughly 0.5 GB per user. Per user is obtaining this much. No, this is for all user per day. Now this is just the storing the messages and all other detail. Now coming on to different things, like we are storing the metadata as well. This is just for content part. The other thing, like the message ID, user ID, we can easily assume it to be 15 GB or like 5 GB a day. And if we try to keep this much data per day for, let's say, 365 days, this can grow like 365 into, I can't compute it, it will be roughly more than 2-3 TB. The data is huge. So what we will do, so what we can do, what WhatsApp does is, basically after some time it tried to move the messages from DB. Let's say after 90 days it tried to move the messages from our database to cold storage. So we call this process as roll up. We will roll up or archive our messages archive message after 90 days. And the other thing is people can use WhatsApp as a media storage, so we can also apply the same thing on S3, that after how much time we want to remove it and kind of thing. So yeah, this is how the high level overview of our system will look like, right? If you have any doubt, please comment and feel free to do that. So yeah, thank you.